we're going to look at the binomial distribution button on the calculator, which is this one right here that says the probability of the binomial and has 3 blanks. So we're going to talk about what those 3 blanks mean. First of all, what the calculator is doing is working through the binomial distribution formula, which is this right here. Okay, so it is a crazy looking formula and it's not very fun to do by hand. So it's nice that the calculator does this for us. So there are 3 variables that you deal with using a binomial distribution. P, which is the probability of success, N, which is the total number of trials, and X, which is the number of successes. So if you remember back, you have to fit these certain, if you remember back in a binomial, you have to fit these certain characteristics to be a binomial distribution or a binomial experiment. 2 of the main ones we talk about are you have to have a set number of trials, which is going to be our N, and you have to have a clear success and failure. So that's why they call this the probability of success and then the number of successes. So we have P, N, and X. This is what the calculator gives us. So what the calculator actually does is the 3 blanks. So the first blank is the N. The second blank is the P. And then you have the less than or equal to part, which is going to be our X, how many we're choosing. So the problem is going to give you a total amount, and then it's going to say you're going to choose exactly a number, or less than this number, or greater than this number. And that's where we got to work with this calculator, because this calculator always defaults to less than or equal to. So let's say we are doing a problem that says the probability is 0.65 that we draw. Let's say we are doing a problem that we have a 65% chance of success. So we have 0.65 probability of success. We have 8 total people, and we're going to see what is the probability that we pick less than or equal to 3 successes. So again, there's a pile of 8, and we want to know the less than or equal to. So if we set up a chart, it would actually look like this. So if it says less than or equal to 3, what that means is what's the probability we draw 3 out of those 8? Or what's the probability we draw 2 out of those 8? Or what's the probability we draw 1 out of 8? Or 0 out of 8? And that would be what the calculator is going to give us. So if we were doing this by hand with this formula, what we'd have to do is we'd have to plug a 3 into this formula and figure out the probability we get a 3. Plug a 2, plug a 1 in, plug a 0, plug all those in, and then add them all up. But the calculator does it for us. So we come over here and we hit the button. So as I said before, the N is the first thing we put, which is 8. Our probability goes next with the 0.65. And then since this one's already less than or equal to, and we are looking for less than or equal to, we don't have to change anything. We just put 3, press enter, and get our answer. Okay. So if it's less than or equal to 3, I'm going to make this note right here. So we have this. Our probability is 0.10609. Okay. So there's about a 10.6% chance that if we have 8 total things and the probability of success is 65, that when we draw 8, we're going to get 0, 1, 2, or 3 about 11% of the time, 10.6% of the time. All right, so now what happens if it says greater than 3? Okay, what happens if it says greater than 3? Well, if it says greater than 3, that's going to be 4, 5, 6, 7, 8. Okay, so if it says greater than 3, we want 4, 5, 6, 7, or 8. Well, if we remember, all probability distributions should add up to be 1. So all we have to do is do that same thing in the calculator and actually do 1 minus that number. 1 minus that number, and we would get our answer. So I'm going to store this and clear it. And if I do 1 minus recall that number, my probability that I get a number greater than 8 is 0.8939. Or greater than 3, I'm sorry. The probability that I get a number greater than 3 would be 0.8939, which if you think about that, again, we have a 65% chance of getting a success. So what's the probability we get 4 successes out of 8, or 5 out of 8, or 6 out of 8, or 7 out of 8, or 8 out of 8? So there's a bigger chance that we're going to get one of those than there is one of these down here, okay, because there's just more numbers up here. All right, so that's less than or equal to and greater than. Let's do a couple more of these. So if I said, let's do x equals 3. So they said, what's the probability we get exactly 3 of these? What's the probability we get exactly 3? Okay, so this one's a little bit tougher. So we have the less than or equal to. We might use that one again. So if we did less than or equal to, that would give us from 3, 2, 1, and 0. If we want to do exactly 3, how we're going to find that is we're actually going to find the 2, 1, and 0, and then subtract the 3, 2, 1, and 0, and that leaves us with just the 3. So I'm going to go back to this calculator, and I'm going to do 8 for my n, 0.65 for my p, and I'm going to do less than or equal to 2. All right, so let's press enter, and I get 0. So x is less than or equal to 2. What do I get? It should be 0.0253318, around that right there. So we have the less than or equal to 2, so we have the 2, 1, and the 0. We also have the 3, 2, 1, and 0 because we did that earlier, so x is less than or equal to 3. And we get 0.10609 when we did that one. So now we have the 3210 and the 210. So if I actually subtract these, that would leave me with just the 3. So I'm going to clear this, and I already have that stored in here, so I can do the recall minus 0.025318. Press enter, and that is going to give me what the exactly 3 is. It is 0.807729. Okay. So to find the exactly, since the calculator gives you the less than or equal to, you have to find what it is at that point, and then find the less than part of that, and that subtract them, and that will leave you with just the equal. So since that might make more sense. Since it's less than or equal to, we'll find the less than or equal to of the number less than that, then find the less than or equal to the 3, and when you subtract them, what it actually does is it takes off this less than part and leaves you with just the equal. And I believe that covers all of the scenarios of the binomial distribution calculator.